Hey y'all, welcome to 4.1a notes. This is properties of exponents, and you've seen this before, so we're going to do a quick review of these properties and how to simplify exponent expressions. You'll see in this top little box here, we have a review of the basic properties. These are properties you should know really, really well and not have to think about them very hard at all. So let's look at a few examples. Let's look here at 1a. We are multiplying bases that are the same. X is the base. When bases are the same and we are multiplying the factors, we add the exponents. So this becomes x to the power of 7. On part B, we're dividing with like bases. The x's are the bases, they're the same. Dividing with like bases, we subtract the powers. So that would be x to the 5th simplified. On part C, x to the power of 0, any value to the power of 0 is always 1. It doesn't matter if it's a variable or a number. Anything to the 0 power is always 1. Try it in the calculator. Type anything you want to, raise it to a power of 0. The answer is going to be 1. Okay? When we raise a power to a power, like in part D, this is taking x squared, raising it to the 3rd power, and taking y to the 5th, raising it to the 3rd power. When we raise a power to another power, we multiply the exponents. So this will be x to the power of 6 times y to the power of 8. Simplified form. On part E, we have a negative exponent, okay? Realize that when you don't have a fraction, over 1 is the way to make something a fraction. A negative exponent flips to the other side of the fraction, and the exponent becomes positive. The base will stay the same. The exponent will change sign when you flip it to the other side of the fraction. So we will flip this x to the negative 4 to the bottom, and that will become x to the positive 4. Now, you cannot leave a numerator blank. So this is 1 over x to the power of 4 as our final simplified answer here. In part F, we have a fraction, and we have that negative exponent in the bottom. It needs to flip to the top. So this will flip to the top as x to the positive 2. We can leave a 1 in the denominator, but it's okay to leave a denominator empty, so we can use x squared here as that result. So there's a quick review of exponent properties. Now we're going to use those to simplify expressions. An expression is completely simplified when there are no negative exponents and when each variable only appears one time. So we want to combine, multiply, whatever, all of the x's, all of the y's into a single factor of x, a single factor of y, or whatever other letters you're using here. Okay, so in part A, we have a parentheses to the 3rd power. That will be x squared to the 3rd times y to the 3rd. We have another parentheses to the 2nd power. This will be 5 to the 2nd power, x to the negative 1 to the 2nd power, y to the 4th to the 2nd power. Okay, x to the 2 to the 3rd, multiply power to a power. It's going to be x to the power of 6, y to the power of 3. 5 squared is 25. X to the negative 1 to the 2nd is x to the negative 2nd. Y to the 4th to the 2nd is y to the power of 8. And remember, all of those all of those factors are being multiplied together. Okay, so writing this, condensing this one more time, we like the coefficients first. We'll put that 25 first. Look at the x's, x to the 6 times x to the negative 2. Those are like bases that we're multiplying. So we add to get x to the power of 4. On the y's, we have y to the 3rd times y to the 8th. So we'll add those exponents, get y to the 11th. So 25 x to the 4th, y to the 11th is our final simplified answer. There's no negative exponents, and there is a single factor of x, a single factor of y. So let's look at B. Okay, treat your, when we have fractions like this, I like to break it up into pieces. I'm going to break the, over here, I'm going to break the fraction up into a piece. 36 over 24 will reduce that fraction. The x's, x to the 4th over x to the 7. And then the y's, y to the negative 2, y to the power of 4. Okay, 36 over 24, both of those divide by 12. So that's a 3 over 2. X to the 4th over x to the 7th. If we divide that out using exponent rules, we subtract. So that will be x to the negative 3. Well, x to the negative 3 can flip to the bottom and become x to the power of positive 3. So another way to think about this is to think about dividing out your powers, or where there are more powers left over. Okay, when we divide x to the 4th by x to the 7th, we're going to get a power of 3. There's more powers in the denominator, so all the leftovers stay in the denominator. For the y's, that y to the negative 2 flips to the bottom, and we'll have the y4th that was already there, and we'll have y to the positive 2 that flipped to the bottom. So then this is y to the positive 6 in the denominator. So our final simplified answer here is 3 over 2x cubed y to the 6. Again, no negative exponents, one factor of x, one factor with y. So now let's check out C. Okay, C and D go together. Okay, what we need to remember is order of operations. Exponents come before multiplying. Okay, and in part C, this negative sign is not in parentheses. So the only part that's being raised to the power of 4 is the 3, not the negative sign. So this is actually like negative 1 times 3 to the power of 4. So this ends up being, 3 to the 4th is 81. So this ends up being negative 81. On part D, the parentheses mean that the negative 3 is being raised to the 4th power, not just the 3. The negative sign is included as well. This is still going to be an 81. A negative to an even power is positive. So part D is positive 81. Parentheses matter. Parentheses matter. Now, another little section here on rational exponents. Rational meaning can be written as a fraction. Rational exponents and radicals, roots, square roots, cube roots, go together. Okay, so x to the power of 1 over b is the same as the b root of x. Okay, meaning x to the 1/2 power is the square root of x, but we don't usually write the 2 when we mean a square root. So another way to express a square root is to raise the value to 1/2 power. Okay, if you have a numerator other than 1, x to the power of a over b, that can actually be written in 2 ways. That denominator is still the root. So it's the b root of x to the power of a. Another way to write that is still the b root of x, but put that in parentheses and put the a power on the outside. Now, one cute little cheesy way to remember this, the a on top is the power. The b on the bottom of that fraction is the root. Plants have roots. Roots are on the bottom. Roots are on the bottom of this fraction. Pretty plants have flowers on top, and that rhymes with power. So yes, I said flower power on top, roots on the bottom. Flowers on top like powers, roots on the bottom just like plants. You can laugh at it, but if it helps you remember, then it's all okay. Now, let's take a look at some examples here. The cube root of x, that x is understood to be to the first power. So that's x to the power goes on top like flowers, 1 over the root is 3. So this is this is x to the 1/3 power. Make sure you're writing that as an exponent. Make sure it looks like an exponent, not x1/3, because that's not an exponent. Looking at b, we have a to the power of, a is raised to the power of 3, power flower goes on top. 4 is the root, roots are on the bottom. So this is a to the power of 3 over 4. C, the cube root of 27. To write this with a rational exponent, that means a fraction again, we take the base 27, that's understood to be to the first power, so 1 on top, over root is 3, 3 goes on the bottom, 27 to the 1/3 power. Now, the cube root of 27 is 3. So this will simplify to 3. And that is because 3 to the 3rd gives us 27. So the cube root of 27 is 3. Okay. Now let's look at D. We have a fourth root of 81 x to the 8th y to the 5th. Okay. Rewriting this with a rational exponent, 81 x to the 8 y to the 5 would get raised to the power of 1 over 4. Okay, now splitting this up into pieces, that's 81 to the 1/4 power. Okay, this would be x to the power of 8 over 4 and y to the power of 5 over 4. Okay, 81 to the 1/4 power is 3, because 3 to the power of 4 is 81. So the fourth root of 81 is 3. X to the 8 over 4 is x squared. And y to the 5 over 4 completes that answer. So 3x squared, y to the power of 5 over 4. Now, let's go the other way. Let's take a rational exponent and let's write it as a radical form. Write in radical form. So we're going to convert this to a radical. The root is on the bottom, that's the 5. The base a is underneath. It goes to the power where the flower is of 2. So this is read the 5th root of a squared, or a to the 2nd power. On part B, 2 to the power of 3 over 5, written as a radical. 5 is the denominator, the bottom, the root. So the 5th root of 2 to the power where the flower is on top, 3. 2 to the 3rd is 8. So this becomes the 5th root of 8. On C, you have a squared b to the 1/3 power as a radical. As a radical, that will be the 3rd root of a squared b. 3rd root of a squared b. Since all the powers under the radical are going to be smaller than that root, this is considered simplified. On part D, we have 64 x to the third, y to the 10th, all raised to the power of 2 over 5. Okay, so we'll take the fifth root of 64 x to the third, y to the 10th, and all of that is squared. All of that is squared. Okay, so if we square everything on the inside, okay, 64 squared is 4096. X to the third squared is x to the power of 6. X to the 10th squared, sorry, that was y to the 10th squared, is y to the power of 20. Okay, now if we can take the fifth root of any of these values, we want to do that. Okay, 64 does not have a fifth root, and when we square it, we still don't have a fifth root. Okay, x to the 6th does not have a fifth root because that 5 will not divide into the 6. But y to the 20th does have a fifth root. Okay, the fifth root of y to the 20th would be y to the 4th, because if we take y to the 4th, raise it to the 20th power, raise it to the 5th power, we do get 20. So that means y to the 4th can come out, and this is the fifth root of 4096 x to the power of 6. Now, we've talked about this very, very briefly a while back, and you probably glazed over it, and it was okay then, but we really need to look at this now. You are going to very soon, November 8th, 9th, have a quick quiz. It's going to be a 2-minute timed quiz, no calculator, counts as a quiz grade, over powers of numbers. Okay, you need to know your perfect squares up to 15, and then don't forget about 20 squared. Okay, you need to know your perfect cubes up to 7 and then 10. You need to know the perfect fourths up to 5 to the power 4 and 10 to the power 4. You need to know some fifth powers, 1 and 2 to the 5th power. Knowing lots of powers of 2 is a good idea, 2 to the 6th. Okay, and then this is supposed to be a sample of the quiz, and I have fixed this more times than I can count, and it won't save. A sample of the quiz looks like this. This is what you'll have. Okay, you'll have a total of 30. Okay, you'll have a total of 30 questions, and it will be a number to a power. Okay, and it will be from this list. Now, you're thinking, why do we have to do this? Because it's going to be used all the time. I'm exaggerating a little when I say all the time, but not much. Okay, if you know that 5 to the third, okay, if you know that 5 to the power of 3 is 125, then you can very easily find the cube root of 125 because it's 5. Okay, so some more examples. Third root of 27, we already did that one today. It's 3 because 3 to the third is 27. Okay, the sixth root of 64 is 2 because 2 to the power of 6 is 64. And so on. Okay, square root of 625. Square root of 625. You're thinking 625, that's a big number. It's 25. Because 25 squared is 625. So you can go backwards very easily. Okay, cube root of 343 is 7. because 7 to the power of 3 is 343. Okay? Any root of 1 is 1. Okay? Square root of 196 is 14 because 14 squared is 196. So you can go backwards very easily when you know these powers. Okay? It's going to be really important as we go through the rest of Unit 4. Okay? So start studying on these now so that you're ready for that quiz. All right, that's all on 4.1a notes. Check Google Classroom for information on your assignment. Bye, y'all.